In this video, we'll discuss chemical equilibrium and writing equilibrium constant expressions. Many chemical reactions do not form chemical equilibria. For example, the reaction of methane and oxygen to make CO2 in water is one in which only products will form, and reactants will never form from products. However, for as many reactions that do not form equilibria, there are many more reactions that do form chemical equilibria. And these are ones in which reactants, for example in this case acetic acid and water, will react to form acetate ion and hydronium ions. However, the hydronium ions and acetate ions that are made will also react with each other to go backwards, so to speak, and make more of the water and acetic acid. And this is what is meant by dynamic chemical equilibrium. Now, this never stops. In fact, reactants and products are constantly being made, but at a certain point, the rates of both the forward and reverse reactions are equal, and so the amounts will stop changing. We use equilibrium constant expressions, Q, in order to assess the state of the equilibrium. We write the equilibrium constant expression in terms of the activities of the products raised to their stoichiometric coefficients divided by the activities of the reactants. Here we use the parentheses as a way of writing activity. Depending on the state of the species, the activity can be approximated for solutions as the molar concentration of that solution, for gases as the pressure of the gas, and for solids and liquids as 1. So we can rewrite the expression Q and approximate it as the molar concentration of hydronium ion times the molar concentration of acetate ion divided by the molar concentration of acetic acid times 1, which is the activity of the pure liquid. And while Q does change over time, eventually Q will stop changing, and when Q reaches equilibrium, we give that value the name K, or the equilibrium constant.